Hello students, in the previous session we had an intuitive idea of derivatives. In this session we shall study about limits. So far the discussion clearly points towards the fact that we need to understand limiting process in greater clarity. We study a few illustrative examples to gain some familiarity with the concept of limits. Consider the function f of x is equal to x square. Look at the graph on your monitor. Y is equal to f of x is equal to x square, where x belongs to R. You will see for various values of x, f of x is equal to x square has different values. For example, for minus 3 x square we have 9, minus 2 4, for minus 1 it is 1, and for 0 it is 0, and for 1 it is 1, and so on for positive integers. On the graph you can see how the graph of f of x is equal to x square looks like. This is your x axis here and this is y axis. Now we observe that as x takes values very close to 0, the value of f of x also moves towards 0. We say limit of f of x as x tends to 0 is equal to 0. The limit of f of x as x tends to 0 is to be thought of as the value f of x should assume at x is equal to 0. In general, as x tends to a, f of x tends to L. Then L is called limit of function f of x, which is symbolically written as limit f of x is equal to L as x tends to 0. Now let us look into another graph of function g of x is equal to modulus of x for every x belonging to R. Look here, the graph is explained as g of x is equal to x when x is greater than or equal to 0, and it is equal to minus x as x is less than 0. You can see how the graph looks like. G of x is equal to mod x. Consider the following function g of x is equal to mod x as x is not equal to 0. Observe that g of 0 is not defined. Computing the value of g of x for values of x very near to 0, we see that the value of g of x moves towards 0. So, limit g of x is equal to 0 as x tends to 0. This is intuitively clear from the graph of y is equal to mod x for x not equal to 0. Let us consider another function h of x is equal to x square minus 4 upon x minus 2, where x is not equal to 2. Compute the value of h of x for values of x very near to 2, but not 2. Convince yourself that all these values are near to 4. This is somewhat strengthened by considering the graph of the function y is equal to h of x given here. You can find the points 2, 0, 0, 2 and 0, 4 on the graph y is equal to h of x. In all these illustrations, the value which the function should assume at a given point x is equal to a did not really depend on how is x tending to a. Note that there are essentially two ways x should approach a number a either from left or from right. That is, all the value of x near a could be less than a or could be greater than a. This naturally leads to two limits, the right hand limit and the left hand limit. Right hand limit of a function f is that value of f of x which is dictated by the values of f of x when x tends to a from the right. Similarly, the left hand limit. To illustrate this, let us take up one more example. Consider the function f of x is equal to 1 whenever x is less than or equal to 0 and f of x is equal to 2 whenever x is greater than 0. The graph of this function is shown in the figure. Here this is your x axis x dash o x and this is y axis y o y dash. You can see the points 0, 1, 0, 2 and it represents y is equal to f of x. It is clear that the value of f at 0 dictated by the values of f of x with x less than or equal to 0 equals 1, that is the left hand limit of f of x at 0 is limit of f of x, x tends to 0 minus is equal to 1. Similarly, the value of f at 0 dictated by the values of f of x with x greater than 0 equals 2, that is the right hand limit of f of x at 0 is limit x tends to 0 plus of f of x is equal to 2. In this case, the right hand and the left hand limits are different and hence we say that the limit of f of x as x tends to 0 does not exist, even though the function is defined at 0. So, we say limit of f of x as x tends to 0 minus is the expected value of f at x is equal to a given the values of f near x to the left of a. This value is called the left hand limit of f at a. Similarly, we say limit f of x as x tends to 0 positive is the expected value of f at x is equal to a given the values of f near x to the right of a. This value is called the right hand limit of f of x at a. If the right and left hand limits coincide, we call that common value as the limit of f of x at x is equal to a and denoted by limit f of x when x tends to a. Let us see some illustrations. Consider the function f of x is equal to x plus 10. We want to find the limit of the function at x is equal to 5. Let us compute the value of the function f for x very near to 5. Some of the points near and to the left of 5 are 4.9, 4.95, 4.99, 4.995 and so on. Values of the function at these points are tabulated here. Similarly, the real number 5.001, 5.01, 5.1 are also points near and to the right of 5. Values of the function at these points are also given here in the table. X varying from 4.9 to 4.95, 4.99, 4.995, 5.001, 5.01 and 5.1, giving the values of the function f of x as 14.9, 14.95, 14.99, 14.995, 15.001, 15.01 and 15.1 respectively. From the table, we deduce that the value of f of x at x is equal to 5 should be greater than 14.995 and less than 15.001. Assuming nothing dramatic happens, between x is equal to 4.995 and 5.001. It is reasonable to assume that the value of the function f of x at x is equal to 5 is dictated by the numbers to the left of 5 is 15, that is limit f of x when x tends to 5 minus is equal to 15. Similarly, when x approaches 5 from the right, f of x should be taking value 15, that is limit f of x when x tends to 5 plus is equal to 15. Hence, it is likely that the left hand limit of f and the right hand limit of f are both equal to 15. Thus, limit of f of x when x tends to 5 minus is equal to limit of f of x as x tends to 5 plus is equal to limit f of x as x tends to 5 is equal to 15. We observe that the value of the function at x is equal to 5 also happens to be equal to 15. Let us see another illustration here. Consider the constant function f of x is equal to 3. Let us try to find its limit at x is equal to 2. This function, being the constant function, takes the same value, that is 3 in each case everywhere, that is its value at points close to 2 is 3. Hence, limit f of x as x tends to 2 minus is equal to limit of function f of x as x tends to 2 plus is equal to limit of f of x as x tends to 2 is equal to 3. Graph of f of x is equal to 3 is anyway the line parallel to x axis through 0, 3, that is limit of f of x is equal to 3 as x tends to a for any real number a. Now, students, it is time to take up the home assignment. Take down the questions. Evaluate the following limits. Question number 1, limit pi r square as r tends to 1. Question number 2, limit 4x plus 3 upon x minus 2 as x tends to 4. Question number 3, limit x to the power 10 plus x to the power 5 plus 1 upon x minus 1 as x tends to negative 1. Thank you.